Hello everyone. In this video, I will introduce the overall service process in the cloud network integration scenario and the brief principles of service automation. The system administrator has the highest right of the entire system and is usually the builder and asset owner of the entire system. There are many different tenants on the public cloud. Each tenant has a tenant administrator, and each tenant administrator manages only resources of the tenant. The resources need to be applied from the system administrator, and then the system administrator delivers resources to the tenant administrator. Generally, tenants have different types of application systems, such as video conference, website, and mailbox. Each type of application system is set up and provisioned by a service administrator. Service requirements for the network are provided to the tenant administrator. The tenant administrator plans and orchestrates the logical networks for the application systems using the limited resources that have been applied for. The service administrator can install service software on the allocated computing resources to provide services for external systems. Now, let's see the functions of the roles in the cloud network integration scenario. What does the system administrator do? During service configuration and deployment, the system administrator needs to create a VDC and configure a resource pool in the VDC. Then the system administrator creates tenant accounts for different tenants and allocates resource quotas to them. What does the tenant administrator do? During service configuration and deployment, the tenant administrator needs to pay attention to the configuration of network resources and computing materials. To configure network, perform the following operations. 1. Create and name a VPC. 2. Create a vRouter. 3. Create a subnet and bind it to the vRouter. 4. Create and configure a VFW. 5. Configure value-added services such as SNAT, EIP, or IPsec. 6. Configure a security access rule and policy. 7. Configure VLB services. To configure computing, perform the following operations. 1. Create a VM, allocate a certain computing resources, and import them into the system. 2. Bind the VM to a subnet. The following uses the OVS directly managed by Neutron in the network overlay scenario as an example to describe how to associate computing with network. The vSwitch deployed in the host is managed by Neutron in the OpenStack, and the control boundary of the Agile Controller DCN is the NVE. The Agile Controller DCN adds a plugin to Neutron for interconnection. The most typical scenario is to bring the VM online. Let's see how the entire system works. The following is performed to bring a VM go online in the cloud network integration scenario. Step 1. Nova sends the RPC to the host in the selected compute node and invokes Nova Compute to reserve resources for the VM. Step 2. Nova invokes the Neutron API to create a port. The port is a virtual port of the VM reserved to be connected to the vSwitch. The virtual port contains the host ID and the MAC IP VLAN information of the VM. Step 3. Nova Compute creates a VM and binds the vSwitch interface to the VM. Step 4. The vSwitch detects that the VM goes online and reports the online VM information of the local port through OpenFlow. Step 5. The Agile Controller DCN functions as a client to initiate an OVSDB request to obtain port ID information. Step 6. The Agile Controller DCN uses the port ID as the index and obtains the MAC IP VLAN information of the VM from the AC agent. Step 7. In the hybrid overlay scenario, the Agile Controller DCN delivers configurations, including VXLAN flow tables for the VM, to the vSwitch through the OpenFlow interface. The flow table information is synchronized to all MVEs with the same VNI of the VM on the local network. In this case, the VM can communicate with each other when layer 2 overlay access is performed across MVE nodes. Step 8. In the network overlay scenario, the Agile Controller DCN needs to deliver VM access configurations, such as mapping between VLANs and BDs, to the ports of the Tor switch connected to the VM. This function depends on the pre-configuration of the Agile Controller DCN. LLDP is used to discover the connection between the host and Tor switch, so that the Agile Controller DCN can learn to which port of the Tor switch to deliver configurations. The Agile Controller DCN delivers the VM access configuration to the access switch, delivers VNI and VBDIF configurations to the VXLAN gateway switch, and associates the VM with the VRF. In this way, the Tenant administrator creates a VM on the cloud platform, configures its resources, and brings it online. In addition, the cloud platform cooperates with Agile Controller DCN to automatically deliver the network configurations used by the VM, enabling that the VM goes online automatically. That's all for today. Thanks for watching. See you next time.